Hello dear student, today we will see a very beautiful reaction in the organic chemistry, and that is Pinacol-Pinacolone Rearrangement reaction. So dear student, substrate in this reaction is vicinal diol. Look at here. And this is catalyzed in the presence of acid, that is, you can take concentrated H2SO4. The product of this reaction is ketone, a carbonyl compound here, okay. So this is your vicinal diol. What is vicinal diol? That is when two OH are on the alternative carbon. Next, this is called as the, what is IUPAC name of this particular compound? 1 2 3 4. So this is 3,3 dimethyl but, parent name is but, 2 ANONE. Okay, so this is 3,3 dimethyl butanol, right? Okay, so this particular part is called as the Pinacol, and this is called as the Pinacolone. Okay, so this is our reaction. Now please look here, we will see. Now let's see the mechanism of this reaction. Look at here. So what was our substrate? CH3 OH C CH3 and OH. So in the first step, what will happen here? Look at here. First part or first step is the protonation step. The oxygen will give electron to the hydrogen and will get converted into the OH2 plus. Look at here. So this will now OH2 plus, correct? Why plus charge came here? Because oxygen has formed 3 bonds. Clear? Now look at very carefully here. This is, as you know, this is called as the bad leaving group, correct? But OH2 is a good leaving group. Why? Because if OH2 is removed from this site, it will get converted into H2O. So this is unstable state, and H2O is a neutral molecule which is stable one. So we say that this OH2 plus is a good leaving group. Okay, and I hope you have studied this particular part in the basics reaction mechanism. Clear? In the next step, OH2 will get removed here, correct? And what you will get here? CH3 CH3 OH, this is C, this is CH3, and here carbocation will be formed, right? Now here, to make more stable carbocation, right, to form more stable carbocation, here 1,2 methyl shift will take place. Let's see. This is carbon number 1, this is carbon number 2. So this methyl group from this position with its 2 electron will shift to this particular carbon, that is carbon number 1. And what will happen here? Look at here. This carbon now, the methyl group come to this position and this carbon will get positive charge, correct? So if you see, this particular carbocation is less stable, but this particular carbocation is more stable. Think about the reason behind it. Why? Yes, again the very basic reason here, and that is, here this is substituted carbocation. Like oxygen can give direct electron to the carbocation, we call it as a back bonding, and because of this carbocation is a highly stable carbocation. Okay, got it? Now what will happen in the next step? As this oxygen will give electron here carbon double bond oxygen, this bond will be formed here. The rest compound will be as it is, and in the last step deprotonation will occur. That is, this 2 electron will be shifted to oxygen and H plus will be removed. Correct? So what you will get here? CH3, C double bond O, this is C, CH3, CH3, and this is CH3. Got it? So initially you have started with vicinal diol, that is Pinacol, and you get next a carbonyl compound called as the Pinacolone. It's a very simple mechanism. Now let's look at some important points in this reaction. Number 1, H plus is used in the first step, but it is again regenerated in the last step. That means H plus is not consumed in this particular reaction. So this H plus is acting as a catalyst here. Got it? So we say Pinacol-Pinacolone rearrangement is an acid-catalyzed reaction. The second important point here is which will be a rate determining step. Yes, think which will be a slowest step in this particular reaction. This is the acid-base reaction. It will be very fast. Next, as OH2 plus is a good leaving group, it will remove again very fast, but this migration will be very slow. Got it? So this particular step is called as the rate determining step, that is 1,2 methyl shift or 1,2 whatever it will be. Okay, so this particular step is the rate determining step. You have to remember this particular point. Got it? Next important point is, if someone asks you what is the driving force of this particular reaction, so there are two answers. Number 1 is formation of the more stable carbocation due to back bonding. We call it as a substituted carbocation. Got it? Because lone pair are direct near to the positive charge. Okay, and second important driving force, which is the most important, is formation of thermodynamically stable compound carbonyl functional group. So these are the two driving force of this particular reaction. So let's write here driving force of the reaction of Pinacol-Pinacolone reaction. Number 1, that is formation of substituted carbocation, and second will be formation of, what you can say, formation of thermodynamically more stable carbonyl functional group. Correct? So this is your carbonyl functional group. Okay, aldehyde or ketone. So please remember this particular point. Now what are the key points of this particular reaction? Number 1, always whenever you are going to solve questions of Pinacol-Pinacolone, first of all always form most stable carbocation. Got it? That means if you look at this particular reaction, if you protonate this OH, then and in the next step this OH will be removed, then carbocation will be formed at this particular site. Got it? You can see, if you have done protonation here, then here will be OH2 plus, and this OH2 plus will be removed and carbocation will be at this position. So the OH where protonation occurs, it will leave and that particular carbon will get converted into the carbocation. So you will protonate that particular OH at particular site where the carbocation, more stable carbocation will be formed. Got it? Okay, let's see the second point. You have to remember here the migratory aptitude. So in this particular reaction, here in this step we have shifted CH3, as both groups are the same, so there were no problem. But if suppose here is a pH group, here is the hydrogen, then what we have to shift, pH or hydrogen? Or suppose this is the CH3, this is the hydrogen, then which group we should migrate? So when such situation comes, you have to remember the migratory aptitude. And what is the migratory aptitude of this particular reaction is, number one is the, you have to shift the hydrogen if it is present. If hydrogen is not present, you have to shift the aryl groups, and if aryl groups are not present, then you have to shift the alkyl groups. Got it? So this is the migratory aptitude. Okay, now you have to remember this particular point. In the aryl function group, there are different types of aryl function group. So you will first migrate a aryl function group which is having electron donating group attached to it, then simple phenyl group, and then a phenyl group which is attached with electron withdrawing groups. Okay, so number one is the hydrogen, then aryl but with electron donating group, then simple aryl phenyl group, and then aryl with the, or phenyl with the electron withdrawing group. In the alkyl, you will first migrate tertiary, then secondary alkyl group, and then primary alkyl group. Okay, so this is the most important point, my dear student. You have to remember this particular thing. Clear? Now let's solve some examples. Question number 1, look at here. They have given methyl, here is OH, this is carbon, ethyl, and OH. Okay, then H plus heat. Now you have to find out the product. So let's look at here. First of all, which OH you will protonate, this or this? We have to check this particular part. If you protonate this particular OH, it will get converted into this particular thing. Look at here, OH2 plus, okay, and if you do protonation of this particular OH, it will get converted into this particular part. Now in the next step, as you know, good leaving group will be removed, that is OH2 will be removed, and you will get here carbocation. Look at here, this is, I will write methyl as CH3 properly so that we can count alpha hydrogen here. Now this is ethyl means CH2 CH3, this is CH2 CH3, so this will be carbocation here and this will be OH. Okay, now look at here, in this case OH will be here and carbocation will be formed here. Now we know that how to find out the stability. Number one is the resonance, then we check hyperconjugation, and then we check inductive effect. So here there is no resonance, so what we have to check, the hyperconjugation. Look at here, so number of alpha H here. Yes, I hope you know how to calculate the alpha H. So alpha H means this is the alpha carbon, this is alpha carbon, this is alpha carbon. So the H directly attached to the alpha carbon is called as the alpha H. So here are 6 alpha H. Okay, and in this position, how many are the alpha H? Yes, this is carbocation, this alpha carbon, alpha carbon, alpha carbon. So 2 and this 2, only 4 alpha H will be there. So more alpha hydrogen, so more is the stability. So which is the more stable compound? Which is the more stable carbocation here? Yes, more alpha H means more stable carbocation. Got it? This will be less stable. So in this way you have to check proper stability, correct? So tell me now, out of these two, this and this, which will be your actual correct site of protonation? Yes, please tell me. If you protonate this particular site, you get the most stable carbocation. If you protonate this particular site, you will get less stable carbocation. And as I told you, first of all you have to form the most stable carbocation. So what is your correct answer? Yes, this will be your correct answer, and this will be a wrong answer. Okay, so correct protonation site will be this. I hope now it is very clear to you. Okay, I will remove this particular part. Okay, and now in the next step what will happen? There will be a, yes, migration. Now what you will migrate here? Both are the ethyl group, that means no issues. You can migrate anyone. Migrate here, what you will get? This is CH3 methyl, CH3 methyl, this is migrated ethyl, then this is C, then ethyl, then this is OH, and this is your carbocation. Got it? In the next step, what will happen? This will give electron to this through the back bonding, and you will get CH3, CH3, ethyl, carbon double bond O. This will be plus, this is ethyl. Okay, and in the last step, deprotonation occurs here. 2 electron will be shifted to oxygen. So final product you will get is methyl methyl, then ethyl, C double bond O, ethyl. Got it? So here ethyl group is shifted to this particular position and carbonyl compound is formed. So this is your Pinacolone product. Okay, so from this question, what is the answer of this question? Yes, methyl C, methyl, ethyl came here, then C double bond O and ethyl. I hope it is very clear to you. Clear? Now next, please solve the next question. Look here. Now I will take here, like let's take methyl here, carbon, methyl, carbon, phenyl group, phenyl group. You know the phenyl group? Yes, this is your phenyl group. Okay, next here is the OH, here is the OH. Now just tell me fast, quickly, the answer of this particular question. H plus and hit. Quickly tell me. Yes. Now I will not going to solve all the steps. Just quickly you tell me what is the answer. Now here we have 2 OH. Now which will protonate first? Okay. Now look at here. If this will protonate, it will get converted into the OH2 plus. If OH2 plus is removed, carbocation will come to this site. Okay. Now if this protonate, this will convert into OH2 plus. If it get removed, carbocation come to this particular site. So which carbocation is more stable? Here carbocation, okay, get proper resonance stabilization from phenyl groups, but here there are only methyl groups. So which carbocation is more stable? This particular. Okay, because here there is a resonance, and we know resonance stabilized carbocation is more stable than hypoconjugation and inductive effect. Got it? So correct site for protonation is this particular site. Got it? Now after protonation, what we will get? Methyl C, that is methyl, then carbon, then phenyl, then OH, and this will be called as the OH2 plus. It will get removed as a good leaving group, and you get a proper stable carbocation here. Okay, but still we can increase the stability of this particular carbocation. So we do the migration, that is 1,2 shift. Now here we have two things, methyl and methyl, so you can shift any one. So shift this, what we will get, that is carbon, methyl, C, phenyl, phenyl. Methyl will come here, and here there will be OH. Okay, and this will be carbocation. So now look at here, this is phenyl or resonance stabilized carbocation, but this is substituted carbocation stabilized by the back bonding. So which carbocation is more stable? This is less stable carbocation, this is more stable carbocation, and this is the driving force of the reaction. That's why the reaction goes in the forward direction. Okay, got it? Otherwise reaction will not be driven in the forward direction. Okay, in the last step what you will get, this two electrons shift to this particular position, hydrogen will be released, and you will get this particular compound. pH, this is pH, and this is the methyl. So this will be your product. I hope it is very clear to you now. Got it? Now let's solve this particular question. Question number 3. CH3CH, this is C, pH, Me, and we took 2OH. Now they have given concentrated H2SO4. Okay, so first step is the again protonation. Yes, now what you will protonate again? If you will protonate this, here will be positive charge. If you protonate this, here will be positive charge. Now look at here, here is the carbon, hydrogen, and methyl. So this carbocation will be there, and if you protonate this, look at here, this carbocation is attached to phenyl and methyl. So tell me which carbocation is more stable? This is resonance stabilized carbocation. So this particular carbocation is more stable. So first protonation will occur at this particular position. Okay, I hope now it is very clear to you. That's why we are taking more examples so that you can understand these things easily, and these are very important questions. So this will protonate here, gives their lone pair to H plus, OH2, there is water will be released, and what you will get, CH3CH, OH, C, phenyl, methyl, and this carbocation. Okay, so here will be again 1,2 shift, but what will shift? Yes, now here methyl group is there and hydrogen. So our migratory aptitude was what? Yes, please remember. Look at here, what was our migratory aptitude? If hydrogen is present, migrate it first. If hydrogen is absent, then migrate aryl group and then alkyl group. So alkyl group means that is CH3 here and H. So here H and CH3, who will migrate first? Hydrogen. Got it? So please remember this migratory aptitude. So you will now shift hydrogen and not methyl group. Okay, so be careful here. So this is CH3, COH, this will be plus C, phenyl group, methyl, and hydrogen. Got it? Now here this carbocation is more stable as because of the back bonding, and you will get this particular thing here. Look at here, okay, and in the last step 2 electron will be taken by the oxygen and H plus will be released, as it is using we are using it as a catalyst. So this will be a final product, pH, methyl, H. Got it? So please remember two important things. Number one, formation of always form more stable carbocation, and number two, migratory aptitude. You have to migrate first hydrogen, then aryl group, and then in the last you have to shift, that is the alkyl groups. Now let's take Last question. There are many questions on this, you can practice, but take one example of the ring expansion so that you can also practice rearrangement reaction here properly. Now look, both are the same site, so you can protonate any OH. Clear? After that, OH will be removed, OH2, and you will get here this will be your carbocation. Got it? Now look at here. This is the four-membered ring, and we know that here ring expansion can occur. Ring will get expanded. Ring expansion can takes place. Okay, so how to do that? 1 2 3, and you have to shift, and you have to shift this particular bond here. Okay, now look at here, what will happen? Positive charge will come here. Got it? And now this oxygen will give electron here. Okay, can I write this particular thing like this? Okay, both are one and the same. And in the last step, H plus will be released, and what product you will get? This is your final product. Okay, we can write this in this fashion as well. This is 5-membered ring, double bond, and this is the 4-membered ring. The most important question student asked me here, sir, here you did ring expansion, but again here this is a 4-membered ring, and here we have chance to go for the ring expansion. Then why you didn't do that? Because if you expand this particular ring, then you will lose, the formation of more thermodynamically stable carbonyl compound. Got it? Because if this bond will shift here, okay, the OH will be remain as it is, and positive charge will come here at this position. So remember, when we are saying that driving force is the C double bond O, so this is a very fast reaction. This will convert into this particular thing. This step will be very fast. So here, do not do ring expansion at this particular thing. When there is a formation of C double bond O, when there is a possibility of formation of C double bond O, do not go for any additional ring expansion. Got it? So such types of questions are being asked in JEE mains and the advanced examination. Okay, thank you so much.